Welcome to the NCERT solutions of alcohols, phenols and ethers. This is Shishir Mittal from Vyas Verification. And what exactly is the importance of this chapter? Well, these are very crucial organic compounds which not only are very useful intermediates in various chemical synthesis, but also they are very important when it comes to application directly. Alcohols, phenols and ethers is a chapter which we are going to cover in such a way. I repeat, this is not a bare minimum routine solution. By the excuse of discussing NCERT, we are going to give as much input as possible with regards to the actual theory, the working mechanisms, and whenever there's a possibility, we'll talk about deeper aspects and deeper theory as well. Are you ready? There we go. Well, the introduction begins with names. Let's talk about naming. IUPAC names for alcohols, phenols and ethers. The first example. Select the longest possible carbon chain. There goes the rule. Yes. And as you select the longest possible carbon chain, well, in this case, you have to also be careful that does that contain the functional group? And it seems, yes, it does contain the functional group very much. Why? Because OH is the functional group and it is present on the longest possible carbon chain. In this case, what would be the longest possible carbon chain? Of course, this would be the longest possible carbon chain. Fine. What is the second step? The second step says, start numbering. And you should start numbering in such a way that the functional group gets lowest possible locants. 1, 2, 3, 1, 2, 3. It is the same. What about this side? 1, 2, 1, 2, 3, 4. No, that is bad. 1, 2, 3, 4, 5, 6, 7. That, my dears, should be the correct order. Fine. So, this is done. But we have not yet decided locants because from this side or that side, in both the cases, OH group does get number 3. So there comes a third rule which has lower priority than first two. But then it says, if locant is getting same number from both the ends, then look for substituents. Whichever side gives you earliest substituent, I repeat, not maximum number of substituents, not maximum number of the counting number or the sum of locants, etc. That rule is not there. Earliest possible substituent should get you, or the precise wording is earliest point of difference would get you the numbering 1, 2. There are two branches on number 2. In this case, there is only one branch on number 2. No, one branch, two branches are better than one branch. So 1, 2, 3, 4, 5. Oh my God, this is the case? Yes, this is the case. And how do we write the name? That's simple. Word root would be pentane. Suffix will be because of OH, all. So this is pentane 3-all. Or this is 3-pentanol. Fine. Anything else? No. No, there is 2,2,4 trimethyl. This is 2,2,4 trimethyl pentane 3-all. Is that all? Yeah, that's all. What about the second one? The second one says it is 2,4 diol. 7 means hepta. So this is heptane 2,4 diol. This is heptane diol. That much we have done. Is there any other substituent? Yes, there is an ethyl group. So this is 5-ethyl heptane 2,4 diol. This is the way we write the names. Let's take a look at the next two. Well, the longest possible carbon chain containing the functional groups. This, my dear, is the longest possible carbon chain containing the functional groups. And if there are more questions here, there are more. Well, this is The longest possible carbon chain. Oh my God. The moment you have benzene ring automatically in most of the cases becomes the parent chain. Otherwise, this is, as you can see, the longest possible carbon chain. Oh, ho, ho. Very interesting. The longest possible carbon chain. Watch carefully here. This is the longest possible carbon chain. I'm just marking the longest possible carbon chains for various cases so that we have everything ready when we begin to name. In this case, I have left it intentionally. I will talk about it when we come back to that. And then, having marked the longest possible carbon chain, what goes next? The numbering. 1, 2, 3, 4. Name it from any end and it just looks identical. What is this? This is butane 2, 3 butane diol. Wow, this is 2, 3 butane diol. That's what we just said. What about this? Well, this looks very symmetric. 1, 2, 3. So this is actually a common name for this is glycerol. But this is also called 1, 2, 3 propane triol, or the very popular glycerol. Glycerol, of course, is the common name. It is not IUPAC name. But then propane triol is a good name. Now we come to phenols. What is a phenol? If OH group is attached to benzene ring, it is called phenol. Okay. What about IUPAC name? Highest possibility is 1, 2. This is the view number 1, 2, 3, 4, like this. So OH gets number 1. This is benzene 1-all. You could say this is 2-methyl. Now parent chain's name now is benzene. 2-methyl benzene 1-all. Are you aware? I hope you are aware. In case you are not, please become aware that this thing is called benzene. You don't say this is cyclohexatriene. No, it is benzene. It goes by a special common name which is accepted by IUPAC. This is 2-methyl benzene 1-all. What about this one? This is 4-methyl benzene 1-all. Wow. Are you aware that they have common names also? This is called O-cresol and this is called P-cresol. These names are not asked, but I'm just sharing the names because you'll very often hear about cresols. And what are cresols? If one OH and one methyl group is attached to benzene ring, you call it a cresol. Neighbors are called orthocresol. 1, 3 is called metacresol and 1, 4 is called paracresol. Right? Let's take up the next questions. What are these ones? Oh, they look more dangerous. Instead of 1, you have 2 methyl groups. That's okay. 1, 2, 3. This is how we number them. Why like this? Why not like this? Earliest point of difference. You start with OH and you number it as 1. Then you go on both the sides, this side and that side. Is there a branch? Yes. Is there a branch? No. If there is no branch, don't go further. Just name it there. This is done. That's how we decide. So now it is, and there is a lowest sum rule? No. There was lowest sum rule 50 years back. IUPAC has changed it since much before my birth also. So let's forget that. This is 2, 5 dimethyl benzene 1-all. Wow. That's how people call it? Yes, this is the way people call it. And what about this one? This is 1, 2, 3, 4, 5, 6. Why not 1, 2, 3? No. The highest priority functional group gets number 1. OH is a functional group. Methyl is just a substituent. OH gets number 1. So this is 2, 6 dimethyl benzene 1-all. Right? And actually this E also will be eaten away. Benzenol. Why? If there's a vowel here, you drop the previous vowel. That's the stupid rule. What about this one? In ethers, these are looked as prefixes. This is RO. RO group in general. What is the rule? It is called alkoxy. So this CH3O is methoxy. So this is methoxy, yes. And if this is methoxy, this is present on a carbon chain, and this is the carbon chain. 1, 2, 3. Propane, yes. So there is methyl and there is methoxy. So 1 methoxy, 2 methyl propane. How do we do this? The parent chain's name, because of 3 carbons, it is called propane. There are 2 substituents, methyl and methoxy. How do we decide which to write first? Well, alphabetical order. Meth is same. O and Y. O comes before Y. So that is why we have written 1 methoxy, 2 methyl. Right? That is the order of writing them alphabetical. The next parts, let's take a look. Oh my God, what is this? This is ethoxy. Ethoxy benzene. Why? Because this seems to be long. 6 carbons anywhere more than 2. So this is ethoxy benzene. What about these ones? Now C7H15 is very dubious. Why? It could have been anything. C7H15 could have many possible structures, and each of these individual structures would have a different name. What do I do? Well, I better write it, but then because there are 7 carbons here already, I might just write this as phenoxy. If I declare this phenoxy, what is the answer to this? I would have to write down all the possibilities of alkyl groups. Should I? There's no option. Let's do that. 7 carbons. 1, 2, 3, 4, 5, 6, 7. Now, if you have 7 carbons like this, how do you put a phenoxy group here? Well, let me show that to you. You could write down OPH. This is 1 phenoxyheptane. Okay. If I write down OPH, this is 2 phenoxyheptane. Okay. And if I write down OPH here, that would be 3 phenoxyheptane. These seem to be awfully large number of compounds. Yes. 1, 2, 3, 4. 1, 2, 3, 4. I have one more possibility. This is 4 phenoxyheptane. Those 4 ethers are possible right straight there. And are there more possibilities? Of course, there are many more. I think I'll need a separate page for them. Let me take out that page and show you the other possible heptanes. Let's take more additional compounds. Well, we have 1, 2, 3, 4, 5, 6, 7. What is this? This is one parent chain, C7H16. This is isoheptane, if you may choose to call it. It is simply 2-methylheptane. I also could have had 3-methylheptane or 4-methylheptane. God bless me now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Actually, this is not new. These are the same. 1, 2, 3, 1, 2, 3. This is 2-methylhexane. Now, I'm supposed to attach OPH groups here. OPH, yes. OPH, yes. OPH. I can just go on. But this list seems to be never ending. These are going to be, 30, 40, 50 compounds. So, honestly, I really don't believe that NCERT would stoop down to a level of bothering the students so much with such a routine exercise. I'm just giving you a taste of, in case I'm just loose about this, what it comes out as. I repeat, these are phenoxy derivatives of the same compound. This is the parent chain. I have not included this. And there are many, many more. There are just 2 heptanes I've talked about, and there are many, many more heptanes around with many more possible compounds. But let me just name them just for the fun. I don't see much fun, but anyway, this is phenoxy. 1, 2, 3, 4, 5, 6. So this is LMNOP. So this is 2-methyl 1-phenoxy hexane. This one? Yes. What about this? This is 2-methyl 2-phenoxyhexane. Then this would be 2-methyl 3-phenoxyhexane. Then there would be 2-methyl 4-phenoxyhexane, 5-phenoxy, 6-phenoxy. Lines are tuck, 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 these compounds. OPH will simply go on changing its location, and you might think that this is the order in which we can number them. But there is a small problem. This is fine. 1-phenoxy, 2-phenoxy, even 3-phenoxy, 4-phenoxy, no problem. The moment you come here, 5-phenoxy, there is a competition. How would you number this? Is this 1, 2, 3, 4, 5? Or 1, 2, 3, 4, 5, 6? Yes, there is a doubt. And honestly, ethers have exactly the same priority as alkyl groups. All prefixes have same priority. Then they are decided in alphabetical order. L, M, N, O, P, M. Methyl is before, phenoxy comes later. So fine. Till here, it is okay. This would be wrong. No. Why? Because in this case, 1, the very first carbon has a substituent. So 1, 2, 3, 4, 5, 6. So this is 5-methyl 1-phenoxyhexane. This is one good point I just wanted to point out. This is the way you should know this, right? So be careful while writing the names. The crux of this, the takeaway from this is, number 1, the alkyl groups have same order of priority as any other prefix like alkoxy. So whichever comes first is given preference. And if there is a tie, so in this case OPH came first, this is given preference. In these cases, like methyl came first, so methyl got the preference, whatever. And in case there is a tie, you have to look for alphabetical order, right? And this brings us to the next compound, which says, well, the parent chain is 1, 2, 3, 4. It is butane. What about this? This is ethoxy. I would write this as 2-ethoxybutane. 2-ethoxybutane. Beautiful butane. There we are.